Hey, Miss Marion here. So we are doing Unit 5, Lesson 7. Get out your starter. And so I want you to answer these questions, and then when you're done, so pause this, answer the questions. When you're done, come back to me. All right, number 1, what is the title? Well, we're talking about cookie sales. Number 2, independent variable. Remember, independent variable is our x. So what's on our x-axis? That is day, or day of the week, if you want to be really specific. Dependent variable, that is our y. So what's on the y-axis? Number of boxes. So Girl Scout cookies, maybe. At what time did they sell the most boxes? Well, let's kind of look at it. Let's follow it along. We're looking at it, so that's kind of a lot. Oh, here's the most. They sold the most on Friday. Okay, and then, so at what time did they sell the least amount of boxes? So that is the smallest. So it's not that one, that's the biggest. Oh, it's on Monday. Okay, so make sure that you have your starter. It's on your paper. And go ahead and put your starter away. And then we're going to get out our workbook. All right, let's turn to page 189. We are looking at Lesson 7. The I can statement is, I can compare inputs and outputs of functions that are represented in different ways. And so go ahead and give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. 4, I can teach it to my friend. Go ahead and give yourself a sentence. Hey, I don't remember what input and outputs are. I don't remember functions. I think I'll do okay with this. However you are feeling about all of these, go ahead and write down that sentence. All right, let's go ahead and let's turn to page 57, kind of 57 to 58. So this actually starts with page 57. If you look at it, it has the number 1 on it, and then on page 58, it has all the rest of it. So I put it on one page for you, and it says, here are 3 different ways of representing functions. How are they alike, and then how are they different? So you are going to notice how I have a sentence frame for you. They are the same because, they are different because. Go ahead, pause, answer that question, and then come back to me. All right, so let's go and look at it. So how are they the same? Well, this y-intercept is 0 because it doesn't have plus anything. This y-intercept is 0 because it goes through 0, 0. And notice how it has p and q. This is 0, 0, 0. So the y-intercepts on all of these are the same, which is 0. They're also all proportional relationships, meaning that they go through 0, 0. And so those are things that could be the same. How are they different? Well, number 1 is an equation, number 2 is a graph, and number 3 is a table. So this is how they are different. You might have something other than that, but it's totally fine. But those are the things that we're looking at. All right, let's go ahead and look at this graph. Let's kind of look at it, read it first. The graph shows the temperature between noon and midday in city A on a certain day. So the graph is city A. Okay, so I'm going to underline that. So we have our graph, city A. Then let's read the rest of it. The table shows the temperature T Fahrenheit and degrees Fahrenheit for hours. Afternoon is city B. So the table is city B. So we have 2 different cities, 2 different ways of showing that, and then we're going to be looking at those. All right, if you're already on page 59, awesome. If you're not, go ahead and look at page 59. And so again, we're comparing these 2 different things. One's a graph, one's a table. And we're going to read number 1. Which city was warmer at 4 p.m.? So compare those 2. Which city is warmer at 4 p.m.? So on the graph, here's 4. We'll go up there. Okay, so that's about 57. So I'm going to say city A is 57 degrees. Then let's look at the tables. 1, 2, 3, 4. Okay, so that's city B. So city B is 62. So which one was warmer, city B. So notice how we're just comparing that graph, and then we're also comparing the table. All right, number 2, which city had a bigger chance change in temperature between 1 and 5 on it? So let's look at the graph. So let's go back to the graph. So 1 starts there, oh, I guess maybe 50. 5 is 58. So let's look at it. So it starts at 50. 5 is 58, so that's about 8 degrees. Then let's look at the table. So 1 starts at 82. 5 goes to 58. I would have to do some math with that. So city B. So we're going to do 58. Well, let's do 82 minus 58. Because we're just trying to find a change on it. So we're going to go ahead and grab our calculator. 82 minus 58. Okay, that's 24 degrees. So which one had a bigger change? That is city B. All right, number 3. How much greater was the highest record temperature in city B than the highest record temperature in city A during this time? So go ahead and answer that question and then come back to me. All right, so they talked about city B first. So city B is the table. So we have 82, 78, 75, 62, 58, 59. Okay, so the highest one on that one is 82. And they're seeing kind of like this difference kind of thing. City A, going la 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 la. Okay, so the highest is here, so that looks like it's 59. So let's grab our calculators. So we're going to do 82 minus 59. So 82 minus 59. Oh, that's 23 degrees. So again, we're still kind of comparing information about both the table and also the graph. All right, so it says compare outputs of the function when the input is 3. So remember which one is output, which one's input. Your input's 3. What is your output? Go ahead and answer that question and then come back to me. All right, so I'm going to start with city A. City A, so we're saying our input is 3. Let's make that a little better. Input is 3. So that's the X value, okay? Input is 3. So then looking at it, what's my output? Probably, I don't know, 54.5. Okay, and then let's look at city B. City B is the table. Input is 3. Output, what goes along with 3? That is 75. So notice again how we're just kind of comparing all of both the graph and the table. So they do represent time frames in 2 different cities, but we can still compare them together because the time frames are the same. The outputs or the temperatures are different. All right, so let's go ahead and let's turn to page 60. So on page 60, we have the volume V of a cube with the edge length S in centimeters is given by the equation V equals S cubed. So it's the volume of a cube. The volume of a sphere is a function of the radius in centimeters, and the graph of this relationship is shown here. So we're actually looking at 2 different things. We're looking at the equation V equals S cubed, so that is the volume of a cube. So I'm going to highlight that. Cube is the equation. Sphere is the graph. Okay, so those are the 2 things that we are comparing at this time. So if you look at number 1, it says, is the volume of the cube with edge length S equals 3 greater or less than the volume of the sphere with radius of 3? So again, we're looking at 2 different things. So let's look at the cube. and I'm going to say volume of the cube. Let's make a little bit more room, okay? So our side length is 3, and we're cubing it. How do you put this in your calculator? Either you can do 3 times 3 times 3, or you can do this 3, and we call it a carrot top. Kind of looks like a roof, and then 3. Both of these will actually give you the same answer. So 3, carrot top 3, oh, that's going to be 27. So the volume of a cube is 27. Then it says, what is the volume of the sphere? The volume of the sphere is the graph. So let's go to 3, come up. So volume, let's write down volume, sphere. And I don't know, it looks like it's going up at 25, so that's probably 115. And all of these are done in like centimeters cubed, 27 centimeters cubed. But just remember that we're just looking at the number. Okay, so we found the 2, now let's compare it. Is the volume of the cube greater or less than? So volume of the cube, well, that's going to be smaller, so it is going to be less than. All right, awesome. So we compared those two. All right, so let's go ahead and look at number 2. If a sphere has the same volume as a cube with an edge length of 5, estimate the radius of the sphere. So this one's kind of working a little bit backwards. It's a little bit confusing, but I understand that, but we're going to kind of work backwards on this. So first of all, we have to go ahead and we have to find the volume of a cube with a side length of 5. So volume of a cube, side length is 5, so remember that's the 5 to the 3rd power, or 5 caret 3. So 5 times 5 times 5, or 5 caret 3 in your calculator, that's 125. So we're using this volume, and then now we're actually going to figure out the sphere stuff, okay? So we're kind of putting stuff together. So now we're going to take the 125, we're going to go to our graph. So it's kind of like, in our way, our starter from yesterday. So if we look at our graph, and I'm going to go up to, so this is 25, 50, 75, 100, 125. I'm going to go to my graph, and we're looking at this point right here. So I'm going to put a point on there. So 125, that point. And then we're looking for the radius that goes along with it. So we're going to take that point, we're going to go down on the graph itself. So if we kind of come down here, this is the point that we're looking for as far as the radius for the sphere. And so remember that this bottom part is radius of a sphere, okay? So what's what that is, okay, let's ask it one more time. So what is that point? Well, if I look at it, we have it as 3 blank and then 3.5. So this is like 3.25. So I'm going to think about probably around 3.1. Okay, if you have something around that, totally works for me. And then this is a length, so it's going to be centimeters is what we're looking at. So the answer for number 2 is 3.1 centimeters, or somewhere around there. All right, number 3, compare the 2 outputs of the 2 volume functions when the inputs are 2. So, so input is 2. The first one, again, we're looking at the volume of a cube. So volume cube. Input is 2, remember, and we did 2 to the 3rd power. So 2 caret 3, or 2 times 2 times 2. What is that answer? That's 8. And remember, it's centimeters cubed for volume. Then, so that's the volume of the cube. Remember, the graph is the volume of the sphere. So if our input is 2, right, what is our output? So that's in between 25 and 50, kind of in between there, right? So what would that go ahead and be? I'm going to say, so we're going to say volume, sphere. We're kind of estimating. So I'm going to say about, sorry, I need a little bit more room, 35 centimeters cubed. Okay, so which one's bigger? Well, the sphere. Which one's smaller? Well, that's the cube. Awesome. So again, we're just comparing 2 different things. This time we're comparing an equation with a graph. and kind of seeing how are they alike and then how are they different. That was our goal for today. All right, if you look at page 61, we haven't really done these, but it's the are you ready for more? Again, the volume V of a cube with edge length, so side length s centimeters, given by the equation V equals s cubed. So we're doing the same kind of thing. Volume of the sphere is a function of the radius, and that is the graph. And it says, estimate the edge length or side length of the cube that has the same volume as the sphere with radius 2.5. So let's make a little bit more room for me. So radius is 2.5. So radius 2.5 coming up here. So with a radius of 2.5, the volume of the sphere, well, what is that going to be? Probably in between the two, so 50, 75. Okay, probably about, I don't know, 62, 63 centimeters cubed. Okay, so now we're going to take that and we have to kind of do it backwards. They said estimate the side length of the cube that has the same volume as a sphere with a radius 2.5. So I have to think about a number multiplied by itself 3 times that is going to be around 63. So I'm just going to kind of play with some numbers for a second. So I'm going to take, let's say side is 3. Or sorry, side is 1. So 1 times 1 times 1 is 1. Okay, that doesn't work. Side is 2. 2 times 2 times 2. That's 8. Side of 3. Side equals 3. Let's do it that way. 3 times 3 times 3. That's 9, 27, right? So side 4. Sorry, need a little bit more room. So side equals 4. Let's fix that. Equals 4 equals 4. So that's 4 times 4 times 4. That's 64. Oh, I wanted 63. That's 64. So we're going to say about 4 centimeters. So again, we're just comparing different ways as far as the difference between the equation. So we had the equation of V equals S cubed and the graph that we have here as far as for the sphere itself. All right, so Elena's family is driven on the freeway at 55 miles per hour. Andre's family is driving on the same freeway but does not have a constant speed. The table shows Andres, so I'm going to say table is Andres. Elena is 55 miles per hour constant speed. And so the table shows every 10 minutes. Okay, so we're going to go ahead and answer some questions go along with this. So number 1, how many miles per minute is 55 miles per hour? Okay, so we're going to have to kind of think about that. So how many minutes are in a mile? Sorry, how many minutes are in an hour? And then kind of working through that to figure out the answer to this one. All right, so I know that there are 60 minutes for 1 hour, and I have my 55 miles for 1 hour. So that means I need to take 55 and I need to divide it by 60. So if we do 55 divided by 60, so we get 0.916 repeated. So I'm going to say about 0.92 miles per minute. Awesome. Okay. Number 2, who had traveled farthest after 5 minutes and then after 10 minutes? Who traveled farthest after 5 minutes and then 10 minutes? Go ahead and answer that question and then come back to me. So let's look at it. Elena. So Elena goes 55 miles per hour. And then we have that 0.92. So let me rewrite that. So it's 0.92 miles per minute. Okay, we're going to use that one, okay? So we're going to take our 5 minutes, we're going to multiply it by 0.92, grab a calculator. And so 5 times 0.92, we get 4.6. So this is 4.6. So Elena traveled 4.6 miles after 5 minutes. Then let's go ahead and let's look at Andre. Andre was the table, right? So if we look at our table, and we have it as 5 minutes. So Andre is 5.1 miles. So who's the farthest? This is the 5 minute. It is Andre. Okay. Now let's look at it as far as the 10 minutes. So that was 5 minutes. So maybe I'll put a label on there. So this is 5 minutes. 5 minutes. Let's do 10 minutes. So again, Elena, we need to go ahead and do some multiplication with that because Elena did the same amount, okay? So we're going to go 10 times 0.92. So it's 10 times 0.92. Oh, that's 9.2 miles. Andre, we're looking at 10. So Andre, he's 9.1 miles. Oops, miles, not minutes. All right, so who won on this one? Well, Elena went further with the 10 minutes. All right, number 3. How long did it take Elena's family to travel as far as Andre's family had traveled after 8 minutes? Okay, so we're comparing them. Andre, 8 minutes. Andre, 8 minutes. That's 7.4. So Andre, so this is 8 minutes. And it's 7.4 miles. So then now we got to figure out, okay, we want to go 7.4 miles, and we have to figure out Lena's. So Lena's was, we were looking at that 0.92 miles per minute. Okay, so then we have it as 0.92. Oh, you know what? I can take that 7.4. I'm going to put this in red. So 7.4, we're going to divide it by the 0.92. Grab a calculator. Okay. So 7.4 divided by 0.92. Ooh. So what is that? Do we have? Okay. We have 8.043347. Right, keep on going, right? Let's make it easier for us. We're going to say 0.84 and minutes. All right, number 4. For both families, the distance in the miles is a function of time in minutes compared to the outputs of these functions when the input is 3. I'm going to go ahead and have you answer this yourself. So go ahead and answer this. So pause, answer it, and then come back to me. All right, so our input is 3. Our output is what? Okay, so I like to do Andre's first. It's the table. It's kind of a little bit easier. So the input is 3. And then output is, well, input is 3. Output would be 3. So Andre, oh, that's Andre. Andre, well, okay, so that's going to be 3 minutes. Oh, sorry. Input is the minutes, output is the miles. So we're going to do miles. Miles. Okay. And then for Elena, so remember we have that 0.92, so we're going to say 0.92 times 3. Grab a calculator. That's going to be 2.76 miles. So again, notice how we're just kind of comparing these two. Andre's family traveled a greater distance after 3 minutes than Elena's, because he went 3 miles, Elena went 2.76 miles. So Andre is the winner on that one. So notice how, again, we're just comparing this. We're comparing pretty much like an equation or information compared to a table. And again, we get the information back from it all. So that was kind of our goal today, is to go ahead and compare different types of equations, graphs, and then also tables was our goal for today. So remember thinking about different functions, how they can be shown: graph, table, and equation. Okay, and some of them, for yourself, you can see which one's easier for you. For me, I really like the tables because it really just kind of shows exactly right there what we're actually looking for. So again, we're comparing inputs and outputs of functions that are represented in different ways. Kind of think about that. If you want to go back and give yourself another number after this lesson, so 1, I don't remember, 2, can I remember it, 3, I do remember it, 4, I can teach it to my friend, that would be great. And that's also on page 189. So you should, again, been given a quiz review. These are the type of questions that we are going to go ahead and go over for our quiz. So first of all, we're trying to find out if something is a function, okay? So remember, this is our pencil test. Remember, we took our pencil, we put it up and down, and we put it on the graph. So think about it as this is my pencil, right? Lovely pencil. It's not drawn correctly. I don't draw. But what was the question that we asked ourselves? Does this graph only touch my pencil once? And if we move it all the way around the graph itself, does this touch my pencil once? Yes. So is this a function? Yes. Yeah, and for number 2, we're going to do the same thing. And you should have a worksheet that goes along with this that you can go ahead and answer those kind of things. If not, you just kind of go along with us. So does this graph touch my pencil only once? Well, no, it's here and here. So this answer is no. And again, we're going to do the same thing again. It's called the vertical line test. We call it the pencil test, though. Does this touch my pencil once? No, it actually touches my pencil twice, so no, it is not a function. Number 4, same kind of thing. Does this graph touch my pencil once? And then we can actually even check in different places also. See how both of these, they only touch it once. So is this a function? Yes, it is. Does the graph touch my pencil only once? Number 5 is a little bit new. Okay, and so what we're going to do is we're looking at groups of points. Okay, so if we look at the first one, we have 0,3, 2,4, 0,6. And the question that we're going to ask to ourselves, are the x values different? So let's look at it. Are all the x values different? Well, no. See how we have a 0 there and a 0 there? So this is no. So is it a function? No, it is not. Let's look at number 2. Are all the x values, so -7 to -10, -4, are the x values different? No. So is this a function? No. Let's look at number 3, 2, 6, and 6. Are all the x values different? No. And then let's look at the last one, -6, -3, 1, and 6. Are all the x values different? Yes. This is -6. This is +6. So is this a function? Yes. Okay. So this is new. It is going to be on your quiz. It is new. So make sure you understand this. Are all the x values different? Yes. If the answer is yes, yes, it's a function. If it's not, then no, it's not a function. All right, so these are graphs, and so I'm going to let you actually try it yourself. So a tomato plant grows taller as a steady pace. A tomato plant grows quickly at first, remains at a constant height during the dry spell, and then grows at a steady pace. And then a tomato plant grows at a slow pace, then grows rapidly with more sun and water. So go ahead and match up the different graphs with the different stories, and then come back to me. All right, so the first one, a tomato plant grows taller at a steady pace. Which one should this one be? This is graph C. Second one, a tomato plant grows quickly at first, remains at a constant height during the dry spell, and then grows quickly at a steady pace. So constant, height, holds that constant height. That one kind of has a constant for a little bit. So this is graph B. And then last one, a tomato plant grows at a slow pace and then grows rapidly. So I agree that this is slow. I also agree that this is kind of rapidly. So this will be graph A. So as a reminder, the different type of questions that we've gone through, it starts with this worksheet. These are the type of questions you're actually going to have on your quiz tomorrow. So make sure you understand these. If not, come in and ask questions before we take it, or if when I say, hey, are there any questions, make sure you go through these, because these are the type of questions that are going to be on your quiz for tomorrow. So for the rest of today, you are going to do lesson practice problems, Unit 5, Lesson 7. You're going to do 1, 2, and 3. I did not like number 4, so cross it out. You are also going to study for the quiz. Okay, so hopefully you understand stuff. If not, go ahead and make sure you ask questions. Make sure you get your stuff done. A lot of you are missing assignments. Get those assignments in also. And so then you're up to par with everything, and then your parents are happy with you. Okay, so thank you for following along with me, and I'll see you later. Bye.